Okay, hello class. So ito na yung first video discussion for your chapter 4, which is lipids. So this is the video discussion for the first part. Okay, so tapos na tayo sa carbohydrates. Now we are going to discussion of different fats and oils that are found in nature and inside the human body. Okay, so you have Chapter 4, Lipids. The behavior of lipids in water, being insoluble, is the key to their importance in nature. So always remember that your lipids are not soluble in water, unlike your carbohydrates. Okay? So you have heard about an oil leak or oil spill in the ocean, which can spread from many miles on the surface of ocean because oil and water do not mix. Okay? So kapag nagkaroon ng oil spill, okay, so it will not naturally disappear. Okay? So there must be an intervention uh, the humans, no? So we must do something para ma-lessen yung oil that was spilled on the ocean. Kasi nga, it will spread miles and miles because your oil is not soluble or hindi siya nagmi-mix with your ocean water. Okay, so yan yung one example kung gaano ka-insoluble ang lipids with your water. This is also the principle of the cell membrane, which is composed of a thin film of lipids. So if you have your anatomy class, human and physiology subject, meron doong chapter in which na-discuss yung presence ng lipids to the cell membrane. Okay? So your cell membrane must be hydrophobic or may part yung cell membrane ninyo that are hydrophobic to prevent the entrance of water. Okay? Para hindi mapuno ng water yung inside ng cell. So your cell membrane also contains or is also composed of a thin film of lipid. So another lipid is wax, which is used to protect fine wood floor. Okay, so yung pinapahid sa sahig, okay, so iba-ibang color, you have red or pwede ring white. So this material adheres to floor and not dissolved in water. Okay, so a lipid's water insolubility and stickiness also create diseases such as atherosclerosis, in which cholesterol-containing lipid partially clog the arteries, limiting the flow of blood. Okay, so yan yung one health problem that is caused by your lipids. Okay, so they are actually present in your bloodstream. So lipids have brought both benefits and problems. However, they are a mixed blessing. Okay, so your lipids have positive um, positive factors and also negative factors. It is just on the individual or sa tao lang no, kung paano mo siya gagamitin ng mabuti. Okay, so because your lipids is also included in a human's diet. Okay, so let's go to lipids, hydrophobic molecules. So your lipids are hydrophobic. When you say hydrophobic, this is water-fearing, meaning they do not mix with your water. So the water is insoluble, oily or greasy biochemical compounds are lipids which can be taken from cells by nonpolar solvents such as benzene, chloroform, or ether. So lipids share no common chemical structure unlike carbohydrates. So kung doon sa carbohydrates natin, meron silang general molecular formula or chemical formula. So for example, in your hexoses, you have C6H12O6, diba? And for your polysaccharides, meron din silang general formula. Sa lipids, although merong iba't ibang klase ng lipids, you have different types of lipids depending on the structure, no, and the size. They don't have the same or they don't have the general formula for all the types because every type of lipid has a different structure. Okay? So, oily, greasy biochemical compounds. Okay? Taken from cells by non-polar solvents. So, ito yung mga non-polar solvents natin for your lipids. You have benzene, your chloroform, and ether. So, there are two important principles for a compound solubility in water, such as if the water molecules bond well to the potential solute, and if the water molecules can still move freely around the dissolved compounds. So these two categories must be checked or present in a compound in order for the compound to be soluble in water. So one example natin dyan is yung carbohydrates. Okay? So when you say if the water molecules bond well to the potential solute, so meaning your solute must be polar. Okay? They must be polar and they must be able to react with your solvent, and they must be able to mix with your solvent. And for the second category, if the water molecules can still move freely around the dissolved compound. So when you say move freely, dapat yung solute, the present sa solvent, ang kanilang molecules are small enough for the water molecules to still move around the solute molecules. Okay? So to illustrate this, let us consider sodium chloride. So sodium chloride is a salt dissolved in water. So it turns into ions in which water molecules form bond and water molecules move freely around the small ion. So kapag tinunong mo or you dissolve this salt or sodium chloride in water, you will form positive and negative ions. Okay? So those ions are small enough in a way that the water molecules can still move freely around them. Okay? And another example is your sucrose or sugar, okay, carbohydrate. Also dissolves in water because it forms hydrogen bond with water and are also very small molecules. So your sucrose, the molecules of your sucrose are actually very reactive with the hydrogen bonds of your water, meaning it is polar. Because your water is a polar solvent, it will also dissolve a polar solute. So, yung lipids natin, they are non-polar. Kaya, they will not be dissolved by your polar water solvent. Okay, so lipid structure and solubility differ from that of the salt, your sodium chloride, and carbohydrates, like your sucrose, because the lipid molecules are big enough to prevent the free movements of water molecule. So sabi nga natin, your lipids does not have a general formula, unlike your carbohydrates. Okay? So meaning, iba-iba ang sizes ng lipids. So you have, when you say lipids, these have long hydrocarbon chain. Okay? Hydrophobic hydrocarbon chain. Meaning, a chain na carbon and hydrogen. So, mas maraming number of hydrocarbons bonding, mas nagiging insoluble yung inyong lipids. So, unlike doon sa carbohydrates natin, that their molecules are generally small, the molecules of your lipids are big. So, kapag malalaki yung molecules, wala nang free movement ang water molecules. Okay, so mixture between lipid and water will be difficult. So you will need what? An emulsifier. Okay, so there is actually a way to mix your lipid and water together, but there should be a presence of an emulsifier. Okay, so mamaya i-take up natin yan. What is an emulsifier? Okay, so aside from that, lipids cannot form hydrogen bond in which carbohydrates can. Okay? So, kasi kapag yung carbohydrates ninyo, when mixed with water, there is hydrogen bonding between the two, no? So, hindi yan present sa lipids natin. So, they can form large number of positive and negative charges present in solution. So, unlike your salt solution that can create positive and negatively charged ions, yung lipids natin, they will not form those kinds of ions. So, another X factor for your lipids. So, lipids are large, relatively non-polar molecules and are water insoluble. Okay, so because of these, lipids are called hydrophobic. So, water-fearing, water-phobic fear. While many carbohydrates and salts are called hydrophilic, so water-loving. So that is the difference between your lipids and carbohydrates. So the common components of lipids are fatty acids. Okay, so kumbaga ito yung monomer no, ng inyong lipids. You have the fatty acids. So when the number of carbon atoms in the fatty acid molecules increases, the water solubility of the fatty acid decreases. So habang humahaba yung chain ng carbon atoms in a fatty acid, its solubility in water also decreases. Okay? So opposite yung kanyang relationship. So increase and decrease. So in butyric acid, your butyric acid is composed of how many carbon atoms? Coming from your butane, okay, you have 4 carbon atoms. So mahaba ba yung chain na yun? No. Okay, so your butyric acid is composed of only 4 carbon atoms. So relatively, it is still soluble in water. Okay, so in butyric acid, the water solubility is infinite because water can easily move around these small or smaller compounds. Kasi nga, 4 lang na carbon atoms. However, with 12 carbon atom molecules and more, okay, 12 carbon atoms composing your lipids, okay, and more, the water cannot move nor form bond, making them insoluble in water. So, lipids that are composed of carbon chain less than 12 carbon atoms are still soluble to water. Pero more than 12 or 12 carbon atoms and more, hindi na sila soluble in water. Okay, so the hydrophobic nature of lipids makes it very important to their biological function. Okay, so actually, yung pagiging water-fearing nila, it is not negative, no? It is not a negative factor because it actually helps in many biological processes found in the body. So their water insolubility allows lipids to serve as barriers to aqueous solutions. So this property makes it important form of cellular membrane. So again, yung cells ninyo, hindi advisable na many water molecules can enter, okay, the cellular membrane. So, yung hydrophobic nature ng inyong lipids provides a protection against water for your cells. So, let's go to classifications of lipids. You have a total of 4 major classifications of lipids, each containing different classifications. So first, you have simple lipids. So lipids are hydrophobic molecules, very large and non-polar. Okay, ito yung mga classifications sila based on structural differences. So these classifications are based on the differences in their structure. You have for simple lipids, you have 2 types of lipids. You have fats and oils and boxes. So your fats and oils, these are esters of fatty acids plus glycerol. Okay, so when you say glycerol, you can also call this as glycerin. Okay, so your glycerol is actually called a polyol structure, okay, or compound. Polyol, P-O-L-Y-O-L, compound, polyol compound. When you say polyol compound, these are compounds containing many hydroxide functional groups. Okay? So, yun, multiple hydroxide or hydroxyl groups. Yung OH group ninyo. Don't forget that. Okay, so when you say polyol compound, this compound contains many or multiple hydroxyl group or OH functional groups. So, yung glycerol natin, may tatlo yan siyang hydroxyl groups or OH groups. So, fats and oils, esters of or products for combination of your fatty acid and a glycerol molecule. Next, you have waxes. So, waxes are esters of high molar mass fatty acids and high molar mass alcohols. Okay? So, when you say high molar mass, napakaraming carbon atoms. Okay? So, fatty acids with many carbon or carbon and hydroxide chain. So, combination ng waxes ng alcohol and fatty acid. Ang fats and oil, combination ng fatty acid and glycerol. Next, second classification, compound lipids. You have three types of compound lipids: phospholipids, sphingolipids, and glycolipids. Your phospholipids are substances that yield glycerol, phosphoric acid, fatty acid, and nitrogenous base upon hydrolysis. So again, what is hydrolysis? This is the use of a water molecule to break down or separate bonds, okay, or linkages. Okay, so when your phospholipids undergo hydrolysis, you have a total of 4 products. Okay, you have the glycerol, a phosphoric acid, a fatty acid, and or fatty acids kasi more than one fatty acid yan siya, and you have your nitrogenous base. Then you have your sphingolipids. These are substances that yield an unsaturated amino alcohol. So when you say unsaturated, it contains double bond. Okay, so kapag remember, saturated only contains single bonds. Okay, while your unsaturated unsaturated either fatty acid ba yan or amino alcohol, they always contain double bonds in the structure. So when you say unsaturated amino alcohol, these are actually alcohols that contain an amino group or amine group. Okay, so nabanggit ko na yan sa last lesson natin. When you say amine group, these are groups containing basic nitrogen molecule. Okay, so meaning your unsaturated amino alcohol is an alcohol with a nitrogen atom connected to it or bonded to it, and it contains double bond in the structure or double linkage. So, yung example ng saturated amino alcohol natin, you call that as sphingosine. Okay, a long-chain fatty acid, phosphoric acid, and nitrogenous base upon hydrolysis. Okay, so yung sphingolipids ninyo will form your sphingosine, a fatty acid molecule, phosphoric acid molecule, and nitrogenous base kapag nag-undergo ng hydrolysis. Next, you have glycolipids. So, these are substances that yield sphingosine, fatty acid, and carbohydrate upon hydrolysis. So, bakit carbohydrate? Diba? From the name itself, glycolipids. Meaning, molecule of carbohydrate combined with the molecule of your lipid. Okay, third classification, you have steroids. So, steroids are substances that has the steroid nucleus, which has 4 fused cyclic rings with a total of 17 carbon structure. So remember, a steroid nucleus is always the same. Okay? It always has the same structure. Ano yung structure niya? 4 fused cyclic rings. 4 na magkakadikit-dikit na cyclic rings. Yung cyclic rings na yun, ang total ng carbon atoms that are contained inside that 4 fused cyclic rings is 17 carbon atoms. Okay? So, yan yung structure ng steroid nucleus. So, your steroid nucleus is located inside the steroids. Okay. Number 4, classification, you have miscellaneous lipids. So these are substances that are insoluble in water such as vitamins like A, D, E, K, and lipoprotein. So para mas madaling matandaan, diretso mo na vitamins added. Okay? Added. A, D, E, K. Okay, so yan yung miscellaneous lipids. So ito siya class, summarization lang ito. And then later on, i-take up yan isa-isa with explanation. Okay. Starting off with simple lipids. Okay, your simple lipids, these are fatty acids. Fatty acids are hydrocarbon chains of various lengths and degree of unsaturation that terminate with carboxylic acid group. So in short, your fatty acids, these are the main component of your lipids. These are the ones that form your lipids. So the structure of your fatty acids is actually carboxylic acid sila. They are carboxylic acid, meaning, so saan yan na lesson? Sa last lesson natin sa polysaccharides, I think, or sa sweeteners. Okay? So, when say carboxylic acid, they contain the structure COOH. Okay, so ang fatty acids niyo, they are carboxylic acids that contain long hydrophobic carbon chain. Meron silang napakahaba na chain ng carbon atoms that are hydrophobic. Yan ang fatty acids. So some of the most common fatty acids are shown in table number 4. So dito mamaya. Okay, so all natural occurring fatty acids have even numbers of carbon. Okay, so yung mga nanggaling sa mga organic natin na fatty acids, they have an even number of carbon atoms. So those with single bonded carbons are saturated fatty acids, and those containing double bonded carbons are unsaturated fatty acids. Okay, so meron kang total of 5 unsaturated fatty acids. So dito. So you will know if it is a straight chain if wala siyang double bond. Okay? Na nakita sa structure niya or sa molecular formula niya or sa condensed formula. Ito. So condensed formula kasi doon sa inyong formula, nakita niyo siya, yung ibang carbon-hydrogen bonds are enclosed inside a parenthesis. Okay, so condensed formula, meaning yan, itong formula ito, for example, your caprylic acid, 1 carbon atom, 2 carbon atom, and then dito sa loob, meaning, itong CH2, i-times mo yan to 4. Meaning, you have a total of 1, 2, 3, 4, 5, 6 carbon atoms. Okay, so itong number outside your parenthesis, this represents the number or the total number of the carbons found inside the parenthesis. So for example, you have here arachidic acid, 20, ang sabi niya 20 carbon atoms itong nasa acid na ito. So kung bilangin mo, 1 carbon atom, 2 carbon atom, and then itong nasa loob, so 1 carbon atom times 18. So 18 plus 2, you have 20, a total of 20 carbon atoms. So condensed formula, kasi kung isulat niyo yan class ng tuloy-tuloy, lalampas na kayo sa paper ninyo. So gagamit kayo ng condensed formula para magkasya pa siya sa paper, okay? So this is what you call a condensed formula. So you have a total of 5 unsaturated fatty acids. So when you say unsaturated fatty acids, these are fatty acids that contain a double bond inside their structure. So you can have actually more than one double bond in a structure of your unsaturated fatty acids. When you see naman saturated fatty acids, wala siyang double bond. So this means na itong chain na ito is continuous lang, straight chain of carbon atoms. Okay, the fatty acids that predominate in the lipids of animals and higher plant cells are palmitic acid, oleic acid, linoleic acid, and stearic acid. So when you say predominate, that means ito yung stronger component. Ano? So this is the main element of the structure. Okay? Main elements of these fatty acids that are found in plants and lipids of animals and higher plants, yung palmitic acid, oleic, and linoleic, and stearic acid. So more than one half of plant and animal fatty acids are unsaturated, with plant lipids having more unsaturated fatty acids than animal lipids. So the melting point increases as the number of carbons increases in saturated fatty acids. So meaning parallel no yung relationship with the number of carbon atoms and the melting point of your saturated fatty acid. So kapag mas maraming number ng carbon atom chain sa saturated fatty acids, mas tumataas din yung melting point niya. However, pagdating sa unsaturated fatty acids, baliktad na, opposite relationship. So meaning, in unsaturated fatty acids, the melting point decreases as the number of double bonds increases of the same carbon atom. So kapag mas marami o mas dumadami yung number ng double bonds present sa structure ng unsaturated fatty acids, mas bumababa or yung melting point niya decreases. Okay? So, yan yung pinagkaiba ng unsaturated and saturated fatty acids. Okay, so unsaturated fatty acids have lower melting point than saturated fatty acids of the same length. So, when you say the same length, class, meaning they have the same total of carbon atoms in the structure. Okay, so pareho lang yung number ng carbon atoms nila sa kanilang structure, pero always, your unsaturated fatty acids will always have a lower melting point compared doon sa saturated fatty acid that have the same number of carbon atoms. Okay, so ito yung 5 unsaturated fatty acids ninyo. You have palmitoleic acid, oleic acid, linoleic acid, linolenic acid, and arachidonic acid. You have naman in your saturated fatty acids, butyric acid, caproic acid, caprylic acid, capric acid, lauric acid, myristic acid, palmitic acid, stearic acid, and arachidic acid. So, ito sila total number ng carbon atoms. Okay, so nakita nyo, palmitic acid and palmitoleic acid, they actually have the same number of total carbon atoms. Magkaiba lang kasi si palmitoleic acid have a double bond. Okay, found on the 7 carbon atom. Okay, so dito sa description sa baba, you have omega or ang symbol ng omega natin parang W, no? So, it is also used in naming the unsaturated fatty acids, followed by the number of carbon atoms before the double bond, starting from the last carbon atom, CH3. So, you have palmitoleic acid. You call this as omega-7, okay? Or yung W7 or W dyan na sign or symbol that means omega. So, you read palmitoleic acid as omega-7. Why omega-7? Let's look at the condensed structural formula of your palmitoleic acid. Always look, class, no? Doon sa, diba, you have your double bond here. Always count the number of carbon atoms before the double bond, the first double bond. So, on the left side. So, dito you have CH3, 1 carbon atom, another CH2 carbon atoms, and then CH2 enclosed in a parenthesis. So, sa labas niya may 5. So, meaning 5 yan na CH2. So, in total, you have 5 carbon atoms plus 2 carbon atoms, you have 7 carbon atoms. That's why you call palmitoleic acid as omega-7. Okay? Fatty acid. Kasi meron siyang 7 carbon atoms before the first double bond. And then you also have oleic acid or omega-9. Kasi you have a total of 9 carbon atoms before the first double bond. You also have omega-6 or linoleic acid. And you also have omega-3 or linolenic acid. And arachidonic acid, which is called as omega-16. Okay, so I hope that is that you've understood what I am trying to explain to you. Okay, so a saturated fatty acid has double bonds, or special characteristics. So you consider the double bonds present doon sa ating unsaturated fatty acids as their special characteristic. Kasi sa kanila lang nakikita yan, which result to formation of geometric isomerism. So remember class, the presence of double bonds in fatty acids represents or it raises the possibility for the formation of geometric isomerism. So if you remember our past lesson doon sa ating stereoisomers, isomers have actually two types. You have the structural isomers and the geometric isomers. So if you still remember, geometric isomerism or geometric isomers have two structures, the cis and trans geometric isomer. So yung presence ng double bonds in unsaturated fatty acids will be the reason for the formation of a geometric isomer. Okay? So for example, your unsaturated fatty acids may be cis and trans isomers. Example natin, you have oleic acid has two structures. Okay? So, ang unsaturated fatty acids natin class will always have two structures. You have the cis and the trans structure. So, for oleic acid, you have cis oleic acid. And for the trans, you have trans oleic acid. So, the trans isomer is almost linear or straight molecule, while the cis isomer introduces a kink into the fatty acid structure as seen in figure number 9. So, kung tingnan ninyo siya, you have the trans. Okay? So, it's almost straight line, diba? Pababa. While yung cis oleic acid natin produces a kink. Okay? So, hindi siya straight. Pab-V siya. Okay? So, yan yung pinagkaiba ng trans geometric isomer sa cis isomer. So, sa trans, opposite, no? Yung chains sa taas and sa baba. While doon sa ating cis geometric isomer, parallel yung location ng inyong chains. So, unsaturated fatty acids found in nature are almost always cis isomers. Okay? Yung organic unsaturated fatty acids natin, they will most likely be coming from the cis isomers. Okay? So, meron silang mga kink. So, they do not solidify easily because the kink or itong bending in their structure cannot stack closely together. So, kasi kapag kinompare mo naman class, ito, diba, your trans structure, meron silang possibility to get closer with each other. Kasi para straight line lang sila. Okay? So, mas compact sila kapag when they stick together. While your cis geometric structure, hindi mo sila mapagtatabi-tabi. Okay? No, it is hard to make them compact. Kasi nga, their structure is not straight and there is a bending, okay, on their structure. So this makes your unsaturated fatty acid to not solidify, okay? So meaning liquid form. Yung inyong saturated fatty acids that are containing a kink or a bend structure because of the presence or because of their cis geometric isomer structure, they will always be liquid or yung most likely fluid sila, very fluid. On the other hand, yung trans fatty or trans-unsaturated fatty acids natin, these are the ones that solidify, meaning bumubuo. Okay? Yung mga oil na nagbubuo or nagsusolidify. Okay? Okay, so kapag trans-unsaturated fatty acid, they are solid. Okay? Most likely solid or turns into solid. While your cis-unsaturated fatty acids, they are most likely fluid kasi hindi magkakadikit-dikit yung kanilang structure because of the presence of the bending or the kink in the structure. Okay, so, they do not solidify easily because of the kink or bend in the structure. This is the reason why unsaturated fatty acids have lower melting point than saturated acids. Kasi nga, mas solid yung saturated acids compared sa unsaturated fatty acids. Even though na same sila na molar mass. So, the more double bonds, the lower the melting point. So, cooking oils are liquids at room temperature because of the high percentage of their fatty acids are unsaturated. Okay, so yung cooking oil kapag nilagay mo sa ref, magsusolidify siya. Pero kapag sa room temperature lang siya, di ba? Always fluid yung inyong cooking oils because most of their fatty acids are unsaturated. So in the same manner, biological membranes are very fluid because of the presence of cis isomers of unsaturated fatty acids. Okay, so the nutritional importance of unsaturated fatty acids have been the focus of many scientists. So if unsaturated fatty acids are converted from cis to trans, they lose their special dietary importance. So kapag kinonvert mo yung cis unsaturated fatty acid to trans, nawawala yung kanyang nutritional value. So, trans isomers are formed when margarine is produced by partially hydrogenating vegetable oils. So, many health organizations suggest the use of softer and less hydrogenated fats. So, mas healthy yung less hydrogenated fats compared doon sa na-transform, na types ng ating trans isomers, okay? Or cis to trans isomers. So, you have linoleic acid, linolenic acid, and arachidonic acid are three common polyunsaturated fatty acids, which represent two nutrient classes which are metabolized differently. So, we have omega positions, omega-3 fatty acids, and omega-6 fatty acids. So, saan doon yung omega-3? You have your linolenic acid. And for the omega-6 fatty acids, you have your linoleic acid and arachidonic acid. So, both cases, wait lang, ayan. Okay, so both classes of polyunsaturated fatty acids are needed for good health. So, ito yung mga nakikita nyo sa certain products, commercial products or sa commercials like your sardines and your pineapple juice ba yun ng Del Monte. So, yan. Meron silang omega-3 and omega-6 fatty acids. So, these two omega fatty acids are very helpful for the health. They are essential fatty acids for animal nutrition and must be present in the diet. So, lacking of these fatty acids in the diet result to impaired growth and reproduction. Okay, so, and skin disorder like eczema and dermatitis. So, when these fatty acids are supplied in diet, and dermatitis disorder symptoms is cleared up, then it means that the cause is deficiency of unsaturated fatty acids. So, meaning kapag gumaling yung dermatitis mo upon having diets of omega-3 and omega-6 fatty acids, then that means that you have a deficiency in unsaturated fatty acids. So you have arachidonic acid and linoleic acid at lesser amount are also used by the body to make hormone-like substances. So the derived biochemical from your arachidonic acid, you call them as eicosanoids. From the Greek word eikosi, meaning 20. So they contain, your eicosanoids contains 20 carbon atoms in their chain. So cell membranes, prostaglandins, leukotrienes, prostacyclins, and thromboxanes belong to this eicosanoid class. So when you say eicosanoids, these are actually signaling molecules, that are formed from the oxidation of your arachidonic acid. Signaling molecules sila na nanggaling sa oxidation ng arachidonic acid, maybe with the use of enzyme or without the use of an enzyme. So you have 4 types of eicosanoids na napoproduce. You have your prostaglandins, leukotrienes, prostacyclins, and thromboxanes. So itong function ng apat na ito, when you say eicosanoids, ang function nila is the same with the function of hormones. So you also call them as fake hormones. So yung true hormones natin, those are produced by the glands, or the endocrine system. Ito sila, they come from the conversion of your arachidonic acid to or arachidonic acid to eicosanoids. So you have cell membranes release arachidonic acid in response to a variety of situations, including infection and allergic reactions. So yung production ng eicosanoids niyo, ang main function nila is for infection and allergic reactions. So the enzymes in the surrounding fluid convert this fatty acid to specific eicosanoids by adding oxygen to the arachidonic acid double bonds. So pinapalitan niya ng oxygen yung double bonds ng ating arachidonic acid to form eicosanoids. So this is done by the enzymes of the surrounding fluid. So your eicosanoids are transported via the bloodstream. So saan sila nag-flow? Sa bloodstream to their site of action unlike true hormones. So yung true hormones kasi natin, they are secreted by the glands, correct? And then the hormones will be carried by the blood flow towards the specific location, kung saan sila dapat magkakaroon ng action. On the other hand, yung inyong eicosanoids, doon sila nag-take action kung saan din sila na-synthesize. Doon sa area kung saan merong infection and allergic reaction. So, diretsyo na sila, direct, kung saan sila na-synthesize or produce, doon din sila magkakaroon ng action. Unlike sa inyong true hormones na kailangan pang dumaan ng bloodstream, dadalhin sila ng bloodstream doon sa area na may need ng action. So the primary cause of swelling, redness, and pain associated with tissue inflammation is your prostaglandins. So thromboxanes are made from platelets in the bloodstream that act as vasoconstrictors and stimulate platelet aggregation as an initial step to blood clotting. So, main function ng thromboxanes ninyo is for blood clotting, meaning for preventing of flowing of blood. Kaya nga, vasoconstriction, meaning yung diameter ng inyong blood vessels constrict, so lumiliit para to prevent the flow of blood, or pwede rin siya, it also stimulates platelet aggregation, meaning pagbubuo-buo ng platelets to form blood clotting, para walang no excess blood will flow. So leukotrienes are made from a variety of white blood cells and other tissues which cause many of the symptoms associated with allergic attack. So, ang main function ng inyong leukotrienes is the action for allergic reactions. So, one example is asthma, which is mediated by your leukotrienes. So, many drugs control one or more of the eicosanoids' physiological effects. Bakit? Kasi yung eicosanoids natin, they form or they are the one responsible for inflammation, di ba? Pain, and reactions, no, of the body for allergic attack. No? So, kailangan i-suppress mo yan, no? Kasi to lessen the pain of the patient. So, meron kang mga iniinom na drugs para ma-stop yung production ng eicosanoids para hindi na ma-stimulate yung certain reactions to allergic reactions and infections, okay, like inflammation and pain. So, the oxidation of arachidonic acid to form prostaglandins and thromboxanes are blocked by non-steroidal anti-inflammatory drugs or NSAIDs. Okay, so remember, your NSAIDs prevents the production, okay, or the conversion of your arachidonic acid to eicosanoids or eicosanoids para ma-prevent mo yung biological or physiological effects nila. So, the common pain relievers such as aspirin, ibuprofen, so ito yung brands, no? Advil, Motrin, Nuprin, Naproxen, and ketoprofen are NSAIDs or NSAIDs. Para mas madali nyo siyang ma-remember class, pwede nyo ng NSAID, okay? NSAIDs. Pero ang pagbasa dyan, NSAIDs. So, they are effective in controlling pain, fever, and inflammation. However, they also have a negative effect sa body. Why? They cause acid damage to the stomach. Okay, so nagkakaroon ng hyperacidity. In fact, about 20% of patients on long-term NSAIDs ID treatment, for example, arthritis sufferers develop stomach ulcers. Okay? So, yung parating umiinom ng mga non-steroidal anti-inflammatory drugs actually develops stomach ulcers. So, because of this side effect, a new group of drugs called COX-2 inhibitors or COX-2 inhibitors has been made to inhibit prostaglandin synthesis for pain control with minimal effect on the stomach. So, ito siya, stomach-friendly siya. Another group of drugs controls leukotriene synthesis, which triggers responsible for asthma attack. So, aspirin has been used to prevent heart attacks and strokes by blocking thromboxane synthesis. Kasi ano kayong effect ng thromboxane para sa blood clotting? So, para decrease, no, or ma-prevent mo yung blockage sa arteries and doon sa vessels, no, or veins that are found in your cardiovascular system, you will, ang iba, umiinom ng aspirin, okay, para ma-prevent yung effect ng thromboxane or ma-prevent yung synthesis ng thromboxane. So, cortisone stop inflammation by blocking the release of arachidonic acid. All of these drugs specific to eicosanoid control emphasizes the importance of these local hormones to life. So, yung releasing ng hormones sa katawan produces different types of reaction. So, yan yung importance ng hormones. Kahit fake hormones ba yan or true hormones. Okay, so you have fats and oils. Let's go to fats and oils. Okay, so the fats and oils are esters of glycerol and high molar mass fatty acids. So in other words, they are formed by reacting glycerol, or you also call glycerol as trihydroxyalcohol, and 3 molecules of fatty acids with this general reaction. So ito, remember class, always study or familiarize the reactions given in the material. Because yung baka pwede kayong ipasulat ng structures or chemical reactions or equations sa exam or quizzes. Okay, so let's try to look at this. So you have the structure of your glycerol. Sabi ko nga, tatlo siyang CH2OH na magkakadugtong-dugtong. Tatlong CH2OH na magkakadugtong-dugtong. So meron silang, sabi ko nga, they are polyols compounds, meaning they contain multiple hydroxyl groups. So ito na yung hydroxyl groups ng glycerol. You have a total of 3 hydroxyl groups inside the structure of your glycerol. So the hydrogen of the OH group of your glycerol will react with the hydroxyl group of your fatty acids. So meron kang 1 molecule of glycerol and 3 molecules of different fatty acids. Magkakaiba-iba sila ha. So, pwedeng magkakapareho, dalawa, ganyan. Pwede rin magkakaiba-iba yung inyong fatty acids dito sa reaction. So, example lang itong R1, R2, R3 para ma-differentiate lang sila. So, when you say R1 or when you say R, this is the hydrocarbon chain. Okay? So, ito yung chain ng carbon atoms. Okay? So, yung OH group ng fatty acids will react with the hydrogen found in the glycerol. Okay? So, magkakaroon ng production of 3 H2O molecules. Kasi, H2O, isa, H2O, pangalawa, H2O, pangatlo. So, nakaproduce ka ng tatlong water molecules and a product called triacyl glycerol or triglyceride. Meaning, combination na yung glycerol and 3 fatty acids. So, yan yung structure nila, okay? So, isang oxygen na lang yung natira sa glycerol and yung oxygen na yun, it bonded with the carbons of your fatty acids. You call this as triacyl glycerol or triglyceride. So, the R's are either long chain of saturated and unsaturated hydrocarbon group. Meaning, yung mga R dyan, pwede siyang continuous straight chain, pwede rin siyang chain of hydrocarbons na merong double bond. So, most of the fatty acids in these esters have 14 to 18 carbon atoms. Meaning, itong R1, R2, and R3, mostly sila ay fatty acids composed of 14 to 18 carbon atoms. So, when water is removed, the product is called triacyl glycerols. Okay? So, tinanggalan mo sila ng water molecules, tatlong water molecules. So, old name niya yung triglyceride, pero commonly used pa rin yan. The 3 R groups are usually different. Magkakaiba-iba sila. So, fats and oils are large molecules with an average of more than 50 carbon atoms per molecule. So, malaki sila, di ba? And have many non-polar uncharged group. When you say non-polar, it does not contain what? A positive and negative charge on the structure. Meaning, they are, kaya nga, uncharged, di ba? Wala silang charge. Walang negative, walang positive. So, they are non-polar, meaning they are not reactive with other substances in other solvents, such as water. So, triglycerols are insoluble in water. Fats normally account for about 25 to 50% of our caloric intake. That is why they are important food source for humans. So, yung fats actually, they are a very good source of energy. Source of energy para sa humans. Fats supply about 40 kilojoules of energy. So, kg is kilojoules of energy per gram or 9.5 kilocalories per gram, more than twice the amount obtained from your carbohydrates and protein. So, di ba, mas malaki yung energy na binibigay ng fats and oils sa human body compared sa carbohydrates and proteins. Okay, so carbon, okay. When they are oxidized to carbon dioxide and water. This is because the carbons in triglycerol are more reduced than those of most other foods. As shown in the following structures, carbon in the carbohydrate has 1 bond to oxygen, while carbon in fat has no bonds to oxygen. So when you say reduce, diba, reaction, meaning you lose a bond, a linkage or a bond to an oxygen molecule. So kung sa carbohydrate, meron ka pang isang bond with your oxygen contained in the OH group, pagdating sa lipids or sa fat natin, wala na carbon or wala nang bonding to a oxygen molecule. Okay? So they are more reduced. Furthermore, the average fat has about 75% carbon by mass, while the average carbohydrate has about 40% carbon. So, mas maraming carbon chain plus mas malaking energy ang nabibigay sa katawan. So, fats are a rich source of biochemical energy. So, in our health-conscious society, fatty foods can be too much of a good thing. That is why scientists have made fat substitutes, which give a creamy texture and taste to foods without energy content of fat. So, dito na naman tayo. Doon sa ating carbohydrates, gumawa ng substitute sugars. Siyempre, hindi pa pahuli yung ibang, yung para sa lipids, no? Meron ding ginawa na naman na substitute for fats, no? So, para hindi masyadong maging obese yung population. Okay, so you have in 1960s a cellulose-based substitute and a processed protein microparticulated are used as fat substitute which are lower in calories than fats. However, neither cooks like a fat. So, effective nga siya, no? Hindi ganun kadami yung calories na nabibigay niya sa katawan. Pero, hindi naman siya kalasa ng fat, no? Iba pa rin talaga if yung original yung gamit, no? So, recently, olestra, a sucrose derivative, has been used as a fat substitute, which is an ester of long-chain fatty acids and sucrose. So, ito siya medyo mas, ang olestra ninyo medyo mas success siya. Okay? So, it tastes and cooks like fat. However, it is indigestible and passes through the digestive tract without giving calories to the diet. So, nalalasahan mo siya as fat, pero actually, hindi siya nadadigest ng stomach or intestines. No? So, walang calories na nabibigay yung inyong olestra. So, these are used by people who are on a diet. So, olestra has been approved for use in snack foods but still, hanggang ngayon, tinitingnan pa rin sa studies if meron ba siyang negative effect if you will use it in long term as an artificial fat. Next, you have waxes. Waxes are esters of high molar mass fatty acids and high molar mass alcohols, combination of fatty acid and alcohol. They are produced by reacting an alcohol with a fatty acid as shown by the equation. Okay, so ito yung equation ninyo. You have your ROH. The ROH is your alcohol. Okay? And then you have your HOC double bond OR as your fatty acid. So when you combine then, you remove a water molecule. So you produce, in the product section, you have one molecule of water. And then, kinombine mo na siya, so may natira kang oxygen dito sa inyong alcohol. That oxygen will bind to the carbon atom of your fatty acid, producing the product. Okay, so the alcohol ROH contributes up to 30 carbons, and fatty acids are COOH also gives an equivalent number of carbons. So water is removed every time wax is produced. Waxes have no polar groups. Okay, so wala din silang positive or negative charge, meaning non-polar sila and they are not reactive to different substances. Very large molecules which represent one of the most hydrophobic classes of lipids. So siya yung grupo na representative sa pagiging pinaka-hydrophobic, okay, among all the types of lipids. Okay, bakit? Kasi napakalaki ng molecule ng boxes. Meaning, napakarami niyang carbon-hydrogen chain. Napakahaba ng carbon chain niya na tuloy-tuloy. Kaya mas mahirap siya mag-react with other groups. So you have boxes serve as protective function due to its extreme water insolubility. Naturally coated with wax are leaves, feathers, fruit, and fur. So yan, di ba? Yan your leaves, feathers, fruit, and fur. These are actually structures that provides protection to animal body. Okay? So meron silang wax component. Many products can be protected by a wax such as hardwood floors, automobile paint, and leather goods. So waxes tend to be the hardest of the lipids because their carbon chain are long and have very few double bonds. Okay? So, hindi, meaning, bakit hard? Meaning solid sila kasi wala silang masyadong double bond. Sabi ko nga, when there's no presence of double bond, mas mataas ang melting point. Meaning, hindi sila ganun kabilis mag-melt. Okay? So, they solidify because their structures are compact together kasi wala silang kink or wala silang bending. Okay? So, very solid yung inyong boxes. Kasi maliit lang ang kanilang double bonds. Okay, next you have compound lipids. The first one is your compound lipid. You have your phospholipid. So your phospholipid are groups of compounds that yield one or more fatty acid, phosphate group, and nitrogenous base upon hydrolysis. So tatlo ang product niya kapag hydrolyze mo siya. The phosphate group have negative charge and nitrogenous base have positive charge. So yung phospholipids, it has a part na hydrophilic or it reacts with molecules of water. Meron siyang part na hydrophilic. Unlike triacylglycerol, phospholipids have a hydrophilic end that interacts with water. Okay? So example natin, ito yung structure ng triacylglycerol. Lahat sila is hydrophobic kasi ang end portion nila is all fatty acids. And sabi nga natin, fatty acids are not soluble in water. Okay, so non-polar man ang fatty acids natin. So, wala ditong hydrophilic group. Now, pagdating mo sa phospholipids, dalawa lang ang hydrophobic kasi dalawa lang ang fatty acid. Yung pinakahuling part niya, it contains the phosphate and the nitrogenous base. Now, these two gives your phospholipid the hydrophilic characteristic. Kasi yung phosphate and nitrogenous base mo, they are highly reactive kasi meron silang negative and positive charge. Okay? So, the lipid with both hydrophobic and hydrophilic character is needed to make membranes. So, kaya nga, di ba, phospholipid membranes doon sa cells natin. Phospholipids are one of the most important membrane components. They are also involved in metabolism of other lipids and non-lipids. Most of the phospholipids that enter the bloodstream are formed in the liver. Okay? Lahat ng cells sa katawan, almost all cells found in the body produces phospholipid. Pero most of them are produced inside the liver. Okay, so phosphatidic acids are glyceryl esters of fatty acids and phosphoric acid. A combination ng inyong fatty acid and phosphoric acid will form phosphatidic acid. Your phosphatidic acid are important intermediate in the synthesis of triacylglycerols and other phospholipids. So ito siya parang pahapyaw lang ito class. Pinakita niya lang yung structure ng phosphatidic acid. Anong function ng phosphatidic acids? Intermediate in the synthesis of triacylglycerols and other phospholipids. So ito yung structure niya. You have the same with the structure of your phospholipid, pero wala siyang nitrogenous base. So, ano lang yung sa kanya? You have the phosphate group lang. And the phosphate group is negative. or has a negative charge. Therefore, it is polar, no? Because it has negative charges and it is reactive with other substances. That's why it is the portion where your phosphate group is found is hydrophilic. Now, other phospholipids are made from phosphatidic acid when specific nitrogen-containing compounds are linked to the phosphate group by ester bond. So, the three commonly used nitrogenous bases are choline, ethanolamine, and L-serine. Okay, so ito yung structures ng choline, ethanolamine, and L-serine. Okay, so sila yung other phospholipids na pwedeng ma-produce from your phosphatidic acid. Okay, so ano yung specific sa structure nila? Yung nitrogen. Okay, you have the nitrogen in their structure. Okay, so phosphatidylcholine. So these are also called as lecithins. So your phosphatidylcholines, these are glyceryl esters of fatty acids, phosphoric acid, and choline. Okay, so sila yung esters na nanggaling sa fatty acid, phosphoric acid, and choline. So meaning, ang structure niya, combination ng fatty acid, meron din siyang phosphate group, and meron siyang structure ng choline na nakikita sa dulo niya. Okay? So you call that as lecithins or phosphatidylcholines. So lecithin is an old term but is still used in commercial products. They are synthesized in the liver and are present in considerable amounts in nerve tissue and brain substances. Your soybean oil is the source of most commercial phosphatidylcholine and contains palmitic acid, stearic acid, palmitoleic acid, oleic acid, linoleic acid, and linolenic acid, and arachidonic acid. Okay, so yung lecithins nyo, pwede siyang makikita sa loob ng katawan, okay? Found or considerable amounts in the nerve tissue and brain substances, pwede rin silang commercially produced, okay? So, one source nila is soybean oil. So, phosphatidylcholine is used extensively in food industry because it is an edible and digestible emulsifying agent. So, ito na. When you say emulsifying agent, this, your emulsifying agent, or you also call this as emulsifier, mixes two substances that are supposed to be not compatible with each other, okay? So, kino-combine nila yung mga substances na hindi nagko-combine sa isa't isa naturally, okay? So, for example natin dyan is yung milk ninyo, okay? So, one example is your milk. So, again, when you say emulsion, or when you say emulsifying agent, these are compounds or substances that act as a stabilizer for emulsions, preventing liquids that ordinarily don't mix with each other. So, ito yung mga liquids na naturally hindi dapat nagmi-mix with each other. So, with the use of an emulsifier, the mixture is being stabilized. Okay? So, mixing makes, or emulsifier or emulsifying agents makes the mixing of two liquids possible. Okay, so emulsion, ito yung colloid formed by combining two liquids that normally don't mix. Okay, so when you mix two liquids that normally don't mix, you will form a colloid. So na-explain ko na kung ano yung colloid, okay? So that is what you call emulsion. So, for example, margarine and chocolate are generally emulsified with phosphatidylcholine. In many pharmaceutical preparations, phosphatidylcholine is also used as an emulsifier. Okay, so an important biological function of phosphatidylcholine is as a membrane component. So, it makes up about 10 to 20% of many membranes. Ito yung structure niya, class. So, sabi ko nga, dalawang fatty acids, R1 and R2. And then sa dulo, okay, you will have your phosphate group and the structure of choline connected to the phosphate group. So, itong part na ito is hydrophilic because they contain negative and positive charge. So, they will be reactive to other substances. Next, you have your phosphatidyl ethanolamines or ethanolamines. You also call them as cephalins. So, these lipids are glyceryl esters of fatty acids, phosphoric acid, and ethanolamine. So, ang pinagkaiba niya, ganun na rin yung structure niya with your lecithin. Ang pinagkaiba lang, ang nakakonect na structure is ethanolamine and not your choline. Okay? So, ethanolamine yung nakakonect sa kanya. So, they are found in all living organisms. Structure niya, you have your glycerol, the original structure of glycerol connected to two different fatty acids or pwede rin the same. And then, the third carbon is connected to a phosphate group and the molecule of your ethanolamine. So, this is also hydrophilic, meaning reactive din siya kasi meron siyang positive and negative charges. So, meaning water-loving ito. Consider this example. Write the formula for phosphatidyl ethanolamine that contains two palmitic acid groups. So, meaning dito sa sample na ito, yung R1 and R2 niya is the same. Dalawang magkaparehong fatty acids. Dalawang palmitic acid groups. So, phosphatidyl ethanolamine is a phospholipid, which means it has a glycerol, a phosphate group, a fatty acid, and a nitrogenous base. So, first, you write the structure of the glycerol. Ito, tatlong CH2OH na magkakadugtong-dugtong. So, next, you add the two palmitic acids to the two carbons in the glycerol using ester bonds. So, when you say ester bonds, class, combination ng OH group ng inyong fatty acid and ng inyong glycerol or other groups with hydroxyl functional groups. Okay? So, esters are functional groups commonly encountered in organic chemistry. So, meron naman siguro kayong past subject na organic chemistry. So, it is characterized by the carbon bond to 3 other atoms. Okay? So, yung carbon mo daw, nakadikit siya or it is bonded with 3 different atoms. Number 1, so yung single bond niya to another carbon. And then, double bond to an oxygen molecule. And then, third, single bond with an oxygen molecule connected to another group. So, for example, dito, this is an example of an ester bond. Ito yung original carbon mo. So, saan yung first connection or bonding? Sa another carbon. Single bonding with CH2. Next, double bond with oxygen. And the next, single bond with an oxygen or another oxygen connected to another group. So, yan yung ester bonds natin. Ito yung structure. Sample ng structure niya. So, ayan, dinikit mo na yung two palmitic acid structures. Okay? So, meaning in this reaction, you've removed two water molecules. After that, connect the phosphate group in the third carbon or bottom of the glycerol using ester bond to form phosphatidic acid. So, after nun, kapag na-connect mo na yung palmitic acid, mag-add ka naman ng phosphate group doon sa third carbon ng glycerol. So, ayan. So, you have your phosphate group. And then lastly, attach the structure of the ethanolamine to the phosphate group. Okay? So, idikit mo na siya. So, tandaan class, always lang magtanggal ng water molecule to form this structure. Okay? So, kanina, may negative bond dito, natanggal na siya. Kasi itong charge dito, actually, bonded with the group of the ethanolamine or the structure of the ethanolamine. But still, meron pa rin siyang positive and negative charge. Okay, so kanina negative for the phosphate group. Ngayon, meron na siyang positive and negative charge. And this makes this structure very reactive. Okay? So, ayun. Yun na yung end niya for now. So, dyan tayo mag-end para sa part 1. Okay? Before the sphingolipids. So, I hope that you study well the writing of the structures because hindi yan mawawala sa quizzes and exam. Okay? So, binigyan ko na kayo ng activity, no? Yung, dito rin yung nakikita nyo na mga activity dito. Dalawa lang. So, try nyo i-practice yan, sulat ng structure no, sa inyong mga bahay or dyan kapag nag-study kayo. Besides the objective part. Kasi yan yung important class. Baka mahulog yan sa writing structures. Okay, so that ends the video discussion for the first part of the lipids. Study well, and I hope that you learned something from watching this discussion. For any further questions, you can just send me personal messages. And the second part will be uploaded next week. Okay, so study well because you will have a quiz maybe on Monday or Monday or next week. So that's all. And